Determine whether the following series converges or diverges, and if it converges, find its sum. The series is the summation from 0 to infinity, 2 times the quantity of 1 over root 2 raised to the n. So we must figure out whether this converges or diverges. And so we have to recognize it as a geometric series. There's some number that's being multiplied from term to term. We call that number the ratio. And that number gets the variable r. In order to find it, we have to write out the first few terms. It'll be easier to find r if we don't simplify. So let's think of the first term. When n is equal to 0, then the 1 over root 2 is raised to the 0 power, and we just get the 2. Now when n is equal to 1, we'll have that same 2, but now it'll be multiplied by 1 over root 2. When n is equal to 2, we'll have 2 times 1 over root 2 squared. When n is equal to 3, we'd have 2 over root 2 cubed, and so on. It's exactly 1 over root 2 that is the value of r. It is the ratio that gets you from one term to the next by multiplying. And so this value of r will tell us whether or not we converge or diverge. The question is it less than 1 in absolute value? And to answer that question, we have to compare root 2 to 1, the denominator to the numerator. Okay, well, hopefully you recognize that root 2 is more than 1. If you square both sides, of course you'll get that since 2 is more than 1, then root 2 is more than 1. And so it turns out, yes, that because we have a denominator that is greater than our numerator, then yes, the value of r in absolute value is less than 1. And so denominator greater than the numerator turns out to be leading you to the conclusion that the entire thing, numerator divided by denominator, is less than 1. Okay, great. Now that we know that it converges, r needs to be less than 1 in absolute value to converge. Now that we know that, it's our job to figure out what the sum is. When a geometric series converges, we can find exactly what the sum is. Okay. And what we find out is that the sum is equal to the first term divided by 1 minus the ratio. And so we have a first term of 2 and a ratio of 1 over root 2. So then our sum will be 2 over 1 minus 1 over root 2. But of course that's not in its most simplified form. Let's go to the next slide to simplify it and get an answer that is representable in its simplest form. So how can we simplify this? We can start out by multiplying numerator and denominator by root 2. What it'll do is it'll clear out this root 2 that's in the denominator here, and then we can see where we go from there. So when we distribute the root 2 through the two terms of the denominator, what we end up with is just a root 2 from the first multiplication, and then these guys cancel and we get a 1 for the second multiplication. Now this would seem to be simplified, but it turns out that it's not. You can't have irrational numbers in your denominator. Root 2 minus 1 is an irrational number. So then how can we make this simplified? What we have to do is rationalize the denominator. we have to multiply numerator and denominator by the conjugate of our denominator in this case. If you have root 2 minus 1, the conjugate would be root 2 plus 1. Why do we need this? What it'll do for us when we multiply the denominator out, it will get rid of the roots. It'll get rid of the irrational numbers from the denominator. Now we also have to do it to the numerator. We can't change the fraction. And so now we'll multiply by root 2 plus 1, both numerator and denominator. You say, well, how's that going to work? When we FOIL this out, root 2 times root 2 is a 2. The middle terms are meant to cancel out. It's like a minus b times a plus b. They cancel. And so then we get the last term, minus 1 times 1, and we get a negative 1. So it turns out to be a nice, simple denominator of 1. Well, what about the numerator? What happens when you distribute the 2 root 2 to the 2 terms in the numerator? What is 2 root 2 times a root 2? Turns out that these guys end up giving you a 2, so you get a 4. And so we end up with the following. We end up with 4 plus 2 root 2 all over 1. Because 2 minus 1 is our denominator. And that's the most simplified form. We could take out a 2, recognizing that both of these guys have a 2. And so we factor out the 2, and we get our final answer in the most simplified form with no irrationals in the denominator, 2 times the quantity of 2 plus root 2.